In this video, I will explain about the equation in boiling. From the previous video, I'm only give you the surface of that equation. Just go through to that equation. Now in this topic, I will explain a little bit deep about that equation in terms of the properties and then the value for that parameters, where you have to refer to that value. Okay, so now we go to the nucleate boiling. So if you before you go for calculation, you have to refer to the question and take a look at the delta T excess. This is what you have to do first. So delta T excess is T surface minus T saturation. So take a look at this delta T excess first. Calculate this delta T excess, and then if your delta T excess in between, okay, 5 degrees Celsius and then 30 degrees Celsius, so you will refer to this nucleate boiling equation. Okay, so to find heat flux for the queued nucleate, you will substitute all the properties inside this equation. Okay, now we have HFG, raw liquid, raw vapor, surface tension, CPL, and then CSF, HFG, N, and T saturation, TS. So for the CSF and N number, you will refer to this figure. So table 10.3. So we have CSF and N. So what you have to do from here, we have the combinations of water, fluid, and heating surface combination. So you have to read carefully from your question. What is the fluid? For example, your fluid is water, and then heating surface combination, heating surface. For example, your water being boiled in stainless steel pan, okay, mechanically polished stainless steel pan. So you take a look at this figure, at this table, and then water, stainless steel, and then mechanically polished, okay, this point, and then you will directly take out this equation, this value, okay, for CSF and N. So that is your CSF and N value, and that will be substitute into this equation. For the other properties will be referred to the T saturation. Okay, other properties will be referred to T saturation. Okay, only CSF and N that will be referred to this table 10.3. So for the surface tension here, we have surface tension. This one, surface tension will be referred to this figure, to this table, table 10.1. So this is for T saturation. Your saturation temperature, for example, you boil water at atmospheric pressure. We know that water at atmospheric pressure, the T saturation is 100 degrees Celsius. Therefore, we take a look at 100 degrees Celsius, and the value for the surface tension is 0.0589 Newton per meter. So that is your surface tension value. Okay, that is for nucleate boiling. And then the peak heat flux or maximum heat flux, as you can remember, memorize back and try to memorize back the graph for the nucleate boiling. So we have these kinds of graph. So point A, B, and C. So this C is a peak value or the peak heat flux. We have heat flux here, so Q dot, and then at x-axis is at delta T excess. So actually this graph comes in order for you to get this curve, you will actually substitute the value of delta T excess one by one into this equation, nucleate boiling equation. We know that this is under nucleate boiling region. Okay, so you will substitute delta T excess one by one into this, then you will get this curve. And after that, at the maximum delta T excess, it will reach to the maximum heat flux. So this equation is actually will turn into this equation at maximum. Okay. So Q dot maximum is this. Sometimes you have to calculate what is the T surface, for example, for the bottom, for the pan, T surface at the bottom of the pan, therefore at maximum. Okay, you do not know how to calculate because in here you have to know what is the Q maximum. So in order for you to determine what is the surface temperature at maximum heat flux, what you have to do is you can equate this equation with this equation, because these two equations is actually the nature is the same. Okay, it comes from the Q dot maximum is comes from this equation, because we plot that graph here, and then at maximum value it will be like this. Okay, this equation comes from the this equation. Okay, at maximum value, so you can equate both of that equation in order for you to determine what is the surface temperature. You already know about the saturation temperature, and then what you have to do is you can calculate what is the TS. Normally the question will ask you about the surface temperature at maximum heat flux. Okay, so in this question, in this equation, we can take a look at the properties of HFG surface tension, and then density, density liquid and density vapor at saturation temperature. Okay, these properties will be referred to saturation temperature. What about CCR? CCR will be referred to table 10.4. So as we can see here, there are three different geometries. So first is flat heater, and then second is cylinder, third is sphere. What you have to do, number one, this is step 1, determine the heater geometry. Is it flat heater or cylinder heater or sphere heater? So based on the configurations of your heater, okay, your geometry of your heater. Let's say your heater is in cylinder, so take a look at these two value. So you will take a look at these two value. That is the number one. We have large horizontal cylinder and then small horizontal cylinder. Next step is to find what is L star. Okay, this is second step. You have to determine what is the L star from this equation. Substitute all the value that are required in this equation. After you determine the L star, so take a look at here. So you will refer only these two. Okay, so we have these two value. So L star, the next step is to compare with this. Okay, third step, either your L star is greater than 1.2 or in between 0.5 to 1.2. Let's say your L is 1.4, so which is L star is greater than 1.2. So you will refer to this radius and then refer to the value of CCR. So this is number 4. So take out this value to replace into or to substitute into Qmax equation. Okay, as you can see here in CCR value, we have different for the flat plate, flat heater, where we have K1 value. So for the small horizontal flat heater, there is another step that you need to do before step number 4. Step number 4 is this, and then you will refer to this. So at the bottom of this table, we have the equation for K1. Calculate and substitute all the value and then return it to this equation to get what is the value for the CCR. So only that geometry is a little bit different compared to the others. So for the other, we have L star to the power of minus 0.25. L star is already calculated here, and then you just powered it with negative 0.25 to get what is the value, and then times with 0.12. So you will get what is the CCR value. So that is how you find the CCR value in to be used in your Q dot maximum. So now this is the minimum heat flux. We know that after it reached to the maximum, and then it will reduce its Q dot heat flux up to the minimum value. So the minimum is normally known as, sometimes known as Leidenfrost point. Leidenfrost. So that equation, if the question asks what is the minimum heat flux, you directly use Q dot max minimum. If the question asks the maximum heat flux, then you directly use Q dot maximum equation. Okay, and the last one is the film boiling. Okay, so the film boiling, we have this equation. So what is the range of the film boiling? So we know that the delta T excess for the film boiling is greater than 120 degrees Celsius. So please check on this delta T excess for the film boiling based on the graph. Okay, so all the properties, okay, for the liquid, only for the film boiling, liquid and HFG, these properties will be referred at T saturation at specified temperature. Specified temperature. And for the vapor, you will refer at film temperature, where Ts plus T saturation, okay, T saturation divided by 2. So you will refer the properties for the vapor at this temperature, film temperature. Okay. So I think that is all for the equation. So first you have to determine, you have to calculate what is the delta T excess. Okay. Before that, in the film boiling, we have C film. C film will refer to this value. So for the horizontal cylinder, you will use 0.62, and then for the spheres, you will refer at 0.67. So let's say your question is horizontal cylinder, so take out the value and then substitute into this equation. So then the rest will be substitute the value. The rest of this value will be referred to this to the table. Okay, based on this line, liquid and HFG at T saturation at specified temperature. For the vapor at film temperature, Ts plus T saturation over 2, only for film boiling. Okay, now the step for you to solve the boiling question, first you have to determine what is the delta T excess. Like I said before, for example, you have T surface is at 108 degrees Celsius, and then you boil water at atmospheric pressure. Okay, atmospheric pressure, we know that the T saturation is 100. So 108 minus 100, you will get 8 degrees Celsius, and it is falls under nucleate boiling, where the nucleate boiling region is in between 5 degrees Celsius to 30 degrees Celsius. And then directly use the nucleate boiling equation and find the properties that required in order for you to solve the Q dot nucleate. Okay, if it is false, for example, your delta T excess is 140, and you boil water at atmospheric pressure, which is the T saturation is 100. 140 minus 100, you have 40. Let's say you have a 240. Okay, and then you boil water at 1 atm, okay, atmospheric pressure, which is the T saturation is at 100 degrees Celsius. So 240 minus 100, you will get 140 degrees Celsius. And then if we refer to the range and it falls under film boiling, delta T excess greater than 120 degrees Celsius. So directly use the Q dot film to find what is the heat flux. Okay. And then for the maximum and minimum value, the question will ask you directly, find the minimum heat flux for the water to boil, or find the maximum heat flux find the maximum heat flux. For the minimum and maximum, the question will ask directly. For the nucleate and film boiling, the equation will give you this surface, and then you have to determine what is the delta T excess, and then directly use the equation. Okay, that's all. Thank you.